x minus, let's make it simple. Go 2 to the x plus 1. Okay.
All right.
Can you tell me the parent function?
Is it, instead of being like 0, 0, it's above the 0 by 1?
Let me just write it for you. 2 to the x is the parent function.
Okay.
So the parent function is the thing that it started out as.
Okay. Parent function thing it started out as.
Right. So like there's a picture that you sent me that has it's got some parent functions on there. It's got an x squared, an absolute value of x, 2 to the x, and x.
Mm-hmm.
Do you see that?
Yes.
So when I ask you for the next question, I say, what is the parent function? You're giving me one of those answers, like one of those functions, one of those 4.
All right.
Okay, let's try that really quick. Let me just try one more here before we jump back to this example. Let's say f of x equals the absolute value of x minus 2. What is the parent function? Before you answer, let me just make it very clear here that these are it's like your multiple choice here.
Mm-hmm.
Which of these is your parent function?
The 2x.
We're talking about this one.
Oh, the x in the bracket.
The absolute value of x.
Mm-hmm.
Right. Okay. I'm hearing a lot of hesitation. Like, is that true? If that's true, let's do a few more of these examples.
Okay. I think that's probably a good idea.
Okay. All right. So let me give you another example here. Sorry, let me just clicking the wrong thing. All right. So let's say f of x equals x squared minus 3. And I ask you, what is the parent function? And do you have that picture up, or should I write that out each time? The x squared, absolute value of x, 2 to the x.
So I can just write it down so that we don't have to keep doing it. X squared, x, 2x, x. Okay. So for that one, it's x squared.
It's this first one, right?
Mm-hmm.
Okay, very good. All right. Now let me try to make these, slightly more difficult. Let's say f of x equals 4x minus 5.
Then it would be f of x, the parent function would be 4x.
Just x.
Just x.
Just x. Yes.
Okay. And it's just x because
the other things, like this is a vertical stretch.
Uh-huh.
And this minus 5 means down 5.
Okay. So it goes down and then taller.
Yes.
That graph. Okay.
Yes.
Yeah, I understand that we use, what's it called? Stretch and
shrink or compress.
Yeah. And what it was, I understand that concept now, because last time I was just having trouble with it. The teacher worded it a good way. Where
Okay.
stretch is going up and down, because it's like if you're pulling on a rubber band.
That's true. Yes.
And then if you like squish a basketball, then it's going out. So I understand that concept now, since I
Great.
that.
That's great. Okay. So what is the parent function for this one here that I've just written to the left?
I think it's just 2x, because
yes,
just like by itself like that.
Yes, the parent function is 2 to the x. Okay, very good. All right, so let me go back to the original one that we're going to do, and let me just copy it down and then talk about what to do next with this.
Mm-hmm.
Okay, so the parent function is 2 to the x. We already said that. And the next thing I want to ask you is, what is the transformation? What is the transformation that you see?
I see that it just becomes 2x, no fx, and no plus 1 is just the 2x, 2 to the x.
The only transformation is this plus 1 here.
Mm-hmm.
So let's review the possible transformations. Okay, so there's a number of them.
5, right?
Sure, there could be more or less depending on them. So What is one transformation that you remember from class?
Negative. Are you asking like the table or are you asking like the name?
Words like imagine I wanted you to do something like in the room, meaning you're standing in the center of the room and I say, go this way or that way. What are some
Oh,
options?
like vertically, like get vertically shifted down,
So let's start with horizontal. So horizontal, you can either go left or right.
left or right.
Okay. And there's an order here that does matter. What's another one that you remember from class?
Vertically.
Okay. So I'm going to put that down here, vertical,
Oh, okay.
and that's up or down. Any other ones? You just mentioned it.
Transform, moved,
A stretch
stretch, and
or,
then
or shrink. And we have to be careful here because you can actually do it both horizontally and vertically. But my
yeah.
guess is you've only talked about it vertically for now.
Uh-huh.
Is that right?
That's the way. Yeah, that is correct.
And there's a third one here, flip over
Oh, right.
x-axis,
Flip, like slash reflect. Right, we were
reflect.
talking about that last time.
Is there another one here that I'm missing that you feel like you've seen or has been mentioned in class? That way we get them all down.
No, I think that is all of them.
Okay. So when I ask you, what is this? When I say, what are the transformations of this function 2 to the x plus 1? I'm saying from the parent function, what is extra? And for each extra piece, you have to tell me, you have to say, well, Matthew, that plus 1 means whichever one of these four that it means.
I think it means that it would be going over,
This one goes up 1 unit.
yeah. So that would it just be vertical?
Yes. So it's a number 4. Do you have any notes on each of these that you feel like is clear, or should we spend a little time trying to cover them? Like I can try and give you the short version of it.
Yeah. Here, wait. I'll just my other notebook's just in the other room. I'll grab that super quickly. I think I
Okay.
might have them in there. Okay. So I have like the y squared. I have the tables flips over the x-axis.
Okay. You got that?
I think I have all of them.
Okay. Let me try and be clear what I'm trying to do here is we really want to get to graphing this, but you need to be able to like step through what is the parent function. You need to like, boom, tell me. And then I ask you, what are the transformations? You need to be like, oh, that's outside.
Up 1 unit.
So it's up 1 unit. And like, no matter what I give you, you have to be able to tell me these pieces of information. And maybe that's where we should focus the lesson for right now.
Okay.
Okay. And what I'll do here is I'll try to only introduce a couple of transformations at a time to help you. And I'll tell you I'll kind of guide you through that. Okay. So let's say our function is 3 absolute value x minus 2. What is the parent function for this?
X.
Absolute value of x.
Okay, absolute value of x.
Can you I'm not sure how to ask this. I'm like, do you visually associate these bars with absolute value of x?
Yes.
Okay.
Like I don't call it absolute value of x, but I
Okay.
can.
So you want to like, when you're like math in some ways is a language, and when you see these vertical bars with the x in between, you want to read it as absolute value of x.
All right, absolutely.
Just like when you saw this, if I said to read f of x equals, you would say 2 to the x. You don't just say 2x, 2 to the x. Like somehow and if you say that to me, I know, oh, it's a little bit above.
Mm-hmm.
Okay. All right. Now, there are two transformations.
So wait, I have a question. So when it's an absolute value problem, will it always be absolute, like have the absolute bars?
Yes.
Okay. I'm ready to go on now.
Okay, so what I'm gonna do is use some colors here to help. So the first transformation is this right here. What is that? What is that? It's inside
It's
parentheses.
moving left
Sorry,
two
right two.
because
It's right two.
oh right, switch. Sorry. I got confused
Okay,
with it.
sorry,
Because
I started writing the wrong thing. And then this one is the second one,
Mhm.
and this is a vertical stretch
Which means it
by
moves
3.
up 3.
Well, it's a, like you said, the rubber band is the best analogy. It literally is like
Yeah.
pulling on a rubber band.
Yeah, so you could say something like it stayed the same but moved up vertically 3 units and 2 to the right.
So I'm not trying to be critical of you. The way you said that implies that there was a number right out here. Stretching is different than moving.
Okay.
And maybe there's a disconnect there in the English language, that's a different
Yeah.
class, but like when we say shifts or moves, we mean this is a shift, is when it literally like does that. Whereas
Mhm.
like you said, there's your rubber band and we stretch it. That's a stretch, that's a move.
Yeah. Okay,
So
so
and just to be clear, they're grading you on the words. Like if you don't say stretch, you're marked wrong.
all right.
You're graded on the words.
All right, all right. So this one is a stretch because there's the brackets.
Because it's out in front. Because it's out in
Okay.
front.
That
Okay.
one's fun.
So notice right is inside parentheses. Left is inside parentheses, like it's inside the function. Okay. So now I'm going to give you the same two transformations, but I'm going to do it with a different parent function. F of x equals 2 to the x minus 2 3 times out in front.
Okay.
What is the parent function?
2 to the x.
2 to the x. And again, there are two transformations.
Mhm.
Right 2, and that comes from this up here.
Yeah.
And then the second one is a vertical stretch
Of 3.
by 3, or of 3. Yes.
So it is vertically stretching up 3.
Okay, you got to be careful. You can't say words like up.
Okay.
Like what I wrote. I'm sorry, it's not cleaner. I'll try and write a little. Is this is what the instructor wants to see.
Okay.
If you write any of those things that you just said, if you say vertical, up, move 3
Mhm.
units, that's completely wrong.
Okay.
And maybe you mean like what I'm saying over here on the left, but it will be marked wrong.
Yeah, what I'm saying is just like not worded right.
And I'm not being critical of you. I'm not telling
Yeah,
you
of
that
course.
anything I'm saying, just like you got to know the constraints here of this problem.
So then, okay, so when it's stretching like this, is the like 0 point moving at all?
Yes.
And then
I'm sorry. No. It's
okay.
moving because of the first one, but not because of the second one.
Yes, so it is moving on the x-axis horizontally 2 units.
That's right. But this does not move that 0 0 unit, like you said,
Yeah,
which in this one is actually 0 1.
0 1. Okay, so instead of being at 0 1, it starts at 0 3.
Yes.
Okay.
But it's also moved right too. So it goes, oh, maybe that's what you meant. Okay. Okay. There's so much here. The right two affects the X value.
Mhm.
The vertical, all the rest of these. Okay. Let me go back here. Horizontal affects the X value. The rest of these affect the Y value.
Horizontal affects x. Okay.
And I really want to get to that. I think we have plenty of time to do that, but like it is important to just be able to list the transformations first before you go into like manipulating the table.
Mhm. Okay. I'm gonna just scrabble that down really quickly.
And again, I'm sending you the notes right away too. So don't feel like, you got to get all this down right this second.
Okay, all right. I'm good to go to the next part.
Okay.
So
Okay. So let me give you a parent function, all the transformations, all 4 of them.
all right.
So let's say f of x equals -3 parentheses x plus 2 squared minus 4. And we're going to do them one at a time here. So this plus 2 would be which way? Is it left or right?
It would be going left because
left.
it switched.
Yes. Okay. Now this, and you can write this if you want, but this left or right only affects the x value. So this 3 out in front is what comes next. And it's a vertical stretch of 3.
And would I say vertical stretch of 3 or -3?
So the negative is we're going to handle differently. The negative, oops, I didn't get the right thickness of line. There it is. The negative there is a reflect over the x-axis.
All right. So the negative before a number will make it be reflecting or flipping over the x-axis.
Yes. And then let me grab another color here. Oh, that one's really thick. 4. This is down 4.
Okay. So the graph starts at 0. No,
What?
1 and 2.
Well, what's the parent function for this one?
The parent function is x
X squared.
Okay.
And I'll just quickly show you. It starts here at 0, 0, goes like that and goes like that, right?
Okay. So then it will move 0, 0, will move on the x-axis 2 units to the left. Then
Okay.
it will vertical stretch of 3. Okay, so my question is for vertical stretch of 3, am I?
So you're stretching the value of 0, which is a little weird, but like you can't stretch 0. So it just stays the same. You can't stretch it and you can't reflect it, but you can move it down 4.
Okay. So I move it down 4 units vertically.
Yes.
And then
Okay, so I let me try to answer your question here. Let me write that function in. F of x equals -3 x plus 2 squared minus 4. So here's your parent function, x and y equals x squared. And then we're going to move each of these points because I think that's what you're trying to accomplish. Okay, so that's 4, 1, 0, 1, 4. Okay, now the easiest one to do is the new x values. So you already answered this. Every x value moves left 2 units. So let's start with the easy one. So 2 moving left 2 units is 0.
0.
1 moving left 2 units is -1. 0 moving left 2 units is -2.
-2, -1 is
-3, and then -5. Okay.
5, sorry.
All right. So then we already, let's come back to 0. So let's talk about what happens to each y value. Okay. The first thing that happens to the y value is that you stretch it by 3, which means multiplying it by 3. And that's why the order matters. So you stretch it, you multiply the y value by 3. So see this y value right here, 4, you're going to multiply that by 3, which is 12. Do you get that? Is that clear?
I think so.
Then you reflect it over the x-axis, so you negate it.
All right.
I don't like doing it this way, by the way. I don't think it's very helpful, but we can do that. We can do it this way.
Right.
And then you go down by 4, so you subtract 4.
Down by 4, subtract 4. So
yes.
Then would it be? It would not be 8. It stays as 12.
It's -16.
Okay. So then
let me try and let me do one more thing with this. because there is a path here to make this clear. So the first one we said it's left 2.
Mm-hmm.
So over here on the right, here's what you do. You say x becomes x minus 2.
All
Or
right.
you could say like subtract 2,
Subtract 2. Okay.
whatever you like, but you have to know that it's for x. Okay. The second one is a vertical stretch of 3. And here's what that means. Y becomes 3 times y, or you can say multiply y by 3. So whatever the y value is, you multiply it by 3.
Okay, so it's going to be bigger than
Yes.
the original.
Yes.
And
And
that's
that's
why
that.
the
And
graph
that's
looks
why we
big.
that's why we took 4 and we multiplied it by 3.
And then that's 12. So instead of being
So then
1
it's
and 4,
reflect.
it's 1 and 12.
So do you see this reflect means y becomes negative y,
Mhm.
or you negate y, because it could be positive. So you negate, or it could be negative. You negate y.
So am I actually, so is this getting flipped over the x-axis? Or?
Yes. So
Okay,
it was 12. Now you negate it. It becomes
negative.
negative 12.
Do you think you'd be able to show me this on the Desmos?
Yes.
Thank you. So then when it's going like down,
Yeah. Let's do one more. So down 4 means that y
then it's
is
going
you're
down.
subtracting 4, or subtract 4.
So it reflects all of that. So the numbers change, reflects. Then you also will move it down 4 units.
Yes.
Okay.
All right. So let me new share this and see if you can like follow along here. I know you can. It's just so let's plot this point 0, 0. Okay, that's the original vertex there. Now our new vertex, or the first thing we did is we went x plus 2 squared. Do you see how everything went left 2?
Yes.
Okay, so what is our new vertex?
Um, New vertex is now -2 and 0.
Yes.
Okay.
Okay. So do you see how that moved that corresponds to that? Maybe let's move this down here.
Yes. So
Okay.
then, boom.
So now do you want me to keep adding to this, or do you want me to like make a new graph each time?
Um,
Because the next thing is to put a 3.
okay. Just you can keep going like this, I think.
Okay, because the
I
problem
think,
is like I don't think it's that much different. Like when you put a
yeah.
3, it's not like, oh, well, it's okay.
Yeah, you can tell what's going on.
So, but like let me try this another way. So let's try a different point. So see how uh 1 is on the original graph.
Yes.
On the stretch graph, it is now 1, 3.
1, 3 because it's multiplied all by 3.
The y value is, but the x value stays
Oh,
the same.
yes. The y value.
Yes, the y value increases is
Well,
multiplied by
is
3.
there ever problems like this where also the x would be multiplied by 3?
Yes, but you don't. So they don't tell you that now, but yes, there is. You don't see it for a while. You actually don't see it until you deal with like square root functions.
All right, yay.
Okay, so here's a negative. Okay, and see how it just moved down over the x. It was positive and now it's negative.
Mhm.
So we had to do 2 things. We had to like multiply y by 3, but then negate it.
All right, and then the last step is to make it
And if I
move.
subtract 4, then this one goes down by 4.
Okay. All right, it's just like steps, and once you got them down.
Yes, yes. Now, from what I remember, you get on this quiz, let me go back or test. You get something like one of these parent functions like I'm giving you, but they give you a couple of graphs here to like work on the transformation. So you don't have to do them all at once if you don't want to.
Mhm.
You know, you can go
Step to step to
step
step.
to step. Yes.
Okay. I think I have to do all mine just on one, but that's all right.
Okay. All right, let's try another one here. So we haven't quite yet got to this, but we need to. So let's do this. 4 times 2 to the x minus 1 minus 3. So again, well, this time there's only 3 transformations. So let's go at them one at a time. What does this minus 1 do? Is it left or right?
It is right.
Right 1 unit. Oh, and what's the parent function?
2 to the x.
Very good. Okay, now this 4 is next. It's out in front.
Therefore, it is multiplying
Vertical stretch
by 4.
by 4. Okay. And then the last one here for this particular problem.
It is moving the y-axis, like vertically going down -3.
Down 3. So again, you got to be careful here. If you say down -3, that actually means up.
Yeah, I just noticed that.
Yeah, you gotta the language here all of a sudden we're like, wait, I didn't think math cared about language. It does.
Yeah. So then you will move it down 3, and then
right. So do you
this one does not flip over the x-axis.
right. That's right. That's correct. So this right one only affects the x value. So you add 1 to x, and that might be like the way you want to like it's important to know that's right one, but you need to know the actual action step, and then multiply when you vertical stretch, multiply y by 4. Then you subtract y by 3. So you have to know what you're doing and which variable you're doing it to.
All right.
And again, I don't really like this way, but it is kind of the way it's taught, I guess. I think there's better ways, but let's just go with this. So you as a student need to know your parent function, your table for this. So you're supposed to know the like -2, -1, 0, 1, 2.
And then you'd get the -2 going into the
So do you notice that these numbers are doubling going this way?
yes.
So they go half the other way. So this is 1/2 and 1/4.
Okay. And then if that was a 3, then it would be like 1/3 and then
1/9. Yes.
okay.
Okay, so let me write this other one here. So it's y equals 4 times 2 to the x minus 1 minus 3. So notice that only the first one here affects the x. Do you see that?
Yes.
So all the x values are moved to the right one, which means you add 1 to all of these x values. Do you follow that?
Yeah, I think so.
See how I just add 1 to each of these?
Yes.
Okay.
1, 2, 3. Oh yeah, that makes sense.
Okay, now the y values, you first multiply the y by 4 and then subtract by 3. The order matters. If you do it in the wrong order, you get the wrong answer. So you multiply this 1/4 times 4, and then which is 1, and then subtract it by 3.
-2.
Multiply 1/2 by 4 and then subtract 3.
-1.
Okay, multiply by 4 and then subtract 3.
1.
Multiply by 4 and then subtract 3.
5.
And the last one here,
9.
they get 13. 4 times 4,
Oh,
16.
16. I don't know why I was doing that.
No problem. No problem. Okay. So this is I mean, this is the key, right? Like if you can identify the transformations, and then you can figure out which variables they affect. Okay. And you know the parent functions, then you can make this transformation.
All right. Yes.
Okay,
so the reason why it worked that way it did, which means going up just a little bit.
Yes.
is because it is multiplying by 4, like the 4 and there's the -3 there. You will multiply the numbers by 4, and then since that -3 is there, subtract it by 3 after that. So it could be 5 and -4. So then you would multiply it by 5, and then once you get that number, you would subtract it by 4.
Are you talking about this one here?
Yeah, like just saying if the 4 was a 5 and
Oh, okay. Yeah. Yes. That's great.
Okay,
Great.
I think I
Okay.
understand that.
Okay. So like I want to do, we got a little more time here. I want to do, I'll just give you a checklist here though. Well, here's what Zach needs to know before the exam for sure. You need to know your 4 parent functions
Mhm.
and you need to know the tables. The table of values. Do you know those or do we need to write those 4 out?
Um,
So I'm talking about y equals x is your first one.
my
talking
chosen x,
about-
that's the base parent.
I'm talking about y equals x squared. I'm talking about y equals absolute value of x. And then I'm talking about y equals 2 to the x. Do you have these 4 parent functions and these down, these
I just
numbers?
wrote those down.
Well, I'm going to write them down here for you so you have them as well.
Thank you. -1, 0, 1, 2.
So, make note cards, do a Quizlet, whatever it is that you need to know these, you've got to have them down in preparation for your test
Set.
tomorrow.
Okay.
Okay,
these
so
will always be the same with those numbers as like
yes.
Okay.
So here's our foundation. If you know these parent functions, and let's assume you know them now, the next thing you need to know is the transformations. If you can figure out the transformations and you can figure out which value they affect, then you can take your parent function table and convert it to the new one.
All right.
So let's do one more example here for that. So let's say f of x equals -2 absolute value x plus 3 minus 7.
-7.
Let's actually make a plus 7.
Okay. The parent function is the absolute value of x.
Very good. There are 4 transformations here, and the first one is this plus 3. What is that first transformation? What is plus 3 when it's inside parentheses?
Vertically moving, horizontally moving to the left by 3 units.
Very good. Okay. The next one is this 2 out in front.
That is, you will stretch it by 2.
Okay. And then how about the negative? What does that do?
The negative makes it flip over the x-axis, reflect over the x-axis.
Okay. And then the last one here, I'm gonna do it in this ugly color here.
Move up 7 units.
Okay. Now, this is great that you've done this, and you have to do it in this order. So try to remember to do it in this order for your test quiz. Now, left 3 units, does that affect the x or the y value?
That will affect, the left 3 units affects the x.
So you subtract x by 3.
Yes.
Vertical stretch by 2, does that affect the x or the y value?
That will affect the y value.
Okay, so y multiply by 3. Does the reflector over the x-axis affect the x or the y value?
It affects the y value.
Okay, so you negate y. Like if it's positive, it becomes negative. If it's negative, it becomes positive. And up 7, does that affect the x or the y value?
That will affect, I mean, technically both, but the y value.
Only affects the y value. Y add 7.
Yes.
Okay. Now, the reason you need to know the parent function is because you go back and you grab this table. you grab your table, or in your case, you're gonna know this so well, you're just gonna write it down on your test.
Mhm.
Okay. You write that down, and then the new X and the new Y you get from these rules you just said. So what happens to the X? You subtract it by 3. So each of these X values you subtract by 3.
-5, -4, -3. Yeah, you beat me to it.
Okay. But do you see how easy that is? If you know the parent function, and if you know the table, and if you write down the correct transformations, do you see how easy that is?
Yes.
Okay. So now a lot of things going on with Y. We have to multiply it by 3, then negate it, then add 7. So I'll help here. What is 2 times 3?
6.
Negate it, -6, and then add 7 to it.
+1.
Okay, good. So for this first one, or I'm sorry, for 1, we're going to multiply by 3,
3.
negate it, so it's -3,
-3.
and then add 7.
10. Wait, it's 4?
So it's 1. Here's what we did 1 times 3, we negated it, and then we added 7.
Oh, okay. I don't know why I was. Yeah.
It's a lot here. It's a lot to hold in
Yeah. And
registers
then
in
the
your
next
brain.
one is 7.
Well, you take 1 and you multiply it by 3. I'm
Mhm.
sorry, you take 0, multiply. Yes, it's 7.
Yeah,
Okay.
0.
And
And then 1, 3 plus 7, 10. And
no,
then the
no, no, no,
next
no, no,
one.
no, no. You gotta do this every time.
Okay.
1 times 3,
+3.
negated, -3. Add 7 is 4.
So, okay, wait. So you always have to put in the negative?
Yes, that's what we said here. Negate it.
Okay. Negate the y. Okay. I got that now.
And then
then,
last one here, and I do have to run because I need at least a minute break here.
yeah.
There are some great videos on YouTube for this. I'm sorry I don't have more. But you take this number, you multiply it by 3, you get 6, you negate it, -6, add 7, you get 1.
Okay.
All right, we do have to stop here, Zach. I'm going to send you
Yeah.
these notes right now. That way you got them. I'll
All
talk to you
right.
next
Thank you
time.
so much,
You're
Matthew.
welcome. Bye now.
Yeah.